boxes that probably cost like $500, and they run heartbeat and OSPF. So they heartbeat between each other, and they distribute internal routes between each other using OSPF. Got a couple of Netgear switches which are like $150 now that do management. So they include STP. I did gigabit Ethernet just because I could. And most boxes behind the scenes have multiple fast D connections, so I can take a switch out and everything will just keep working. So far, 100% working. Rebooted switches, done kernel updates and everything. Some retard behind there got DOS because I guess they posted something on some forum that people didn't like, and it just went like 120,000 packets per second of UDP traffic. It just didn't care. And it was actually natting this stuff at the same time. So, Linux is a really good system for doing this kind of stuff. Obviously, you can't compare that to, say, a Cisco router that every time it sees one of these 120,000 packets per second, it has to do this massive lookup in its rib of all of the 150,000 BGP routes, and it goes, oh, every time. So, it's not an equal comparison to Cisco stuff, but if you wanted to load BGP onto Linux and then do the same tests, then you could see what happens. Essentially, that's what it looks like. It's kind of ugly, but it's tidy. Now, this is basically what it cost. Cheap. Netgear switches are cheap. So FSM 726S. We found a website on the internet that sold these things for $150, and they're refurbs, but they work really well. They give you 24 fast E ports, 2 gig ports. So you can either do gig Ethernet or gig Ethernet over copper or gig fiber using GBICs, and they basically just work really well. You can do VLANs, STP. It'll let you set up a bunch of different stuff. You can SNMP them. They're basically great for little distribution switches. Probably don't want to run them on a big network as a core, simply because they don't really have enough backplane speed to handle a lot of stuff. Netgear do have some gigabit gear that I like, that gives you like 24, 10, 100, 1000 ports. Linux boxes, they're basically just Pentium 4 3.06 gigahertz Pentium 4s with a gig of memory and 3 disks in RAID 5 using software 8. So they cost about $600. They're not going to break the bank. Gigabit Ethernet fiber cards, Netgear GA620s. That is not an error. They were 99 cents on eBay, and I got 5 of them. So I got lots of spares. I think the shipping was like $6. But yeah, they were cheap as hell. So you can pick up this stuff really cheap. Now the one problem we did have is that the drivers that those cards use, it's called async driver. In the kernel, it doesn't do hardware checksumming, which is kind of crappy. However, one of the problems with this was that in one of the kernels, somebody decided, I'm not going to clear that when I have a fragmented packet. So it just basically broke the whole thing. So I went for about 2 weeks trying to figure this out, and eventually got a patch together that fixed it. Now it did. I mean, I literally had all the time in the world to get this thing up and running. It did take me 2 weeks to make it all work, simply because I was poking at it all the time like a lunatic. But it is actually up and running in production now. It works really well. So this is something that you really need to understand it before you implement it. Put it on a test network with the identical amount of stuff, identical traffic. Like actually sit it right next to the production network and have it running there. Because one of the issues I had was I could only replicate it with a fragmented UDP packet coming from somebody in Korea, and I didn't get them very often. So it took literally just a week just to figure out what the packet was that made it break. Then it took another week to figure out how to fix it. Now, the interesting thing was, once I figured out what the packet was, I got a patch from the Linux kernel people in like 20 minutes that fixed it, which is scary. So, for those people out there who have problems with their Cisco gear or their Microsoft stuff, I mean, the Linux community is just really good at fixing stuff. So it ended up being a pretty serious problem in terms of fragmentation of packets. That I think it ended up in 2.6.11 or something. So pretty useful, pretty interesting process of learning, because I know a lot more about all of the low-level stuff in the kernel now than I used to. So I can usually debug stuff pretty well. Okay, what was learned by this whole building process? Never assume the Linux stuff works, because it probably won't. especially with older cards, like anything more than a year old, it's probably not even maintained anymore. There's a lot of stagnated drivers out there. So you want to test them really well, test it under load, and like throw a whole load of traffic over it. I mean, don't just ping flood the thing. Actually, like set up FTP, do some transfers, TFTP, do some UDP stuff, all that kind of thing. You know, cheap hardware has its benefits. You know, if you can spend $4,000 on a big ass server, or you can spend $4,000 on 10 really little ones that if they break, you just go, okay, and it's still running. I mean, it's a lot different. So it's a different sort of way of looking at network provisioning. I wouldn't say go out and buy like little tower boxes that cost $250 and use them as web servers. You still do have to have some, you know, realistic bounds. But certainly what you can do is get smaller boxes, get lots of them, and when they break, you can actually just replace them. You know, if you spend $5-6 on a box, even if you have 4-hour turnaround on parts, that's still 4 hours of downtime if it breaks. Now, 4 hours of downtime till you get the part to fix whatever broke. So you may still have another 10 hours of whatever to get it working really well. So you know, recovering from backups, blah blah blah. So if you have a configuration that just recovers well from failures, then you can work around that. Micro Center. Anybody here shop at Micro Center? Anybody here bought something from Micro Center and it not worked? Anybody here bought something from Micro Center, returned it, and then bought the same thing again? That's what we think they do, but they probably do. Basically, I've bought probably 6 motherboards from Newegg on the internet. They all work. I bought 3 motherboards from Micro Center. None of them work. So, I think something funky is going on with Micro Center. So basically, don't buy stuff from Micro Center. Don't buy motherboards. Other stuff works. You know, like hard drives, I've only had to RMA 2 of them so far out of 7. So I'm doing pretty well. But yeah, unless it's in a sealed box with the original tag on it, wouldn't. Especially that clearance table. It's on clearance for a reason. Okay, last night I had a disk die on me, which was really great because I could actually demonstrate failover. So as you can see, about 2:30, something went completely apeshit on me. And the first box decided it was going to die. The great thing is the second box said, it's dead. I'm going to handle all its traffic. So as you can see, all the traffic moved from one box to the other. It's kind of difficult to tell simply because the graphs aren't the same. This top graph, the top part's 10 meg, the bottom graph, the top part's about 6.5 meg. So it's the graph scaling's off. But certainly, I mean, it was literally like that. There's probably less than 10 seconds of downtime. So everything still kept working. I didn't know it was broken until I came in this morning and tried to SSH into the box and it wasn't there. So you know, it does have some advantages. So hey, you know your stuff works really well when you don't even know it's broken. So
that's what Microsoft says.
Well, brokenness is an illusion. So you know, you can just migrate traffic back and forth. And this runs a whole ton of different things. It actually has some voice over IP stuff behind it that I use from home. And you know, I used voice over IP this morning, and it just still worked. And I didn't even know this stuff was down. So you can do a lot of weird things with it, and it's obviously pretty flexible.
Do you have no cloth behind that?
Yes. That's what
the next time we get slashed out, it'll be able to handle it?
I will. Can you read it? You're like, I don't know. Obviously, the one advantage of this is that if you have multiple services, say, for example, like the top box that died was running a DNS server. Well, because it was actually running through NAT on itself, when the second one came up, it assumed the IP address of that DNS server. So the DNS stuff still works, even though it's running on a completely different box. So it's all pretty flexible in the way it works. Once you start playing with NAT on Linux, the whole concept of this service runs on this box is just thrown out the window. It's this service runs on this IP address, which is NATed to the internet on this IP address that people see. So you can just move stuff around all over the place and nobody notices. So there's a lot of flexibility there. And obviously, 2:30 in the morning, am I going to get out of bed to fix a router? No. So the fact that it still works is obviously a good thing. and everything behind it kept on working. So this wasn't planned, by the way. This just actually happened out of damned unluckiness, or whatever the word is. Something hates me, so yeah. So that's my contact info. If anybody wants to take notes, anybody cares. Websites. Linux-ha.org has lots of stuff on Heartbeat, lots of stuff on using Linux for HA stuff, using DRDB, all that kind of good stuff. LinuxVirtualServer.org is where IPVS lives. If you want to set that up on a network, then lots of things there. And then there's lartc.org, Linux Advanced Routing and Traffic Control How-To. It's basically just this giant documentation that tells you how to use all the crazy networking stuff in Linux that nobody else documents. So there's a tool called IPRoute2 that if you use Linux and haven't got it, you should probably get it. It will let you do everything to the Linux kernel that you want in terms of networking. It will do all of the crazy routing stuff. It will let you route based on source port. I mean, it will do stupid stuff like that. So if you want to route all of your outbound IRC traffic via a dial-up, you can. I mean, it's pretty useful. I actually use it to do traffic prioritization on a DSL and a cable modem. So all my voice over IP traffic goes via the DSL modem because it's only like 20 milliseconds away from the VoIP gateway. All of my heavy traffic, like FTP, HTTP, all that kind of junk, BitTorrent, goes out the cable modem, and it works really well. In general, the lartc site is a really, really good resource for Linux because it will explain how to do a lot of the stuff that you could normally only do with high-end Cisco gear, high-end Foundry Juniper stuff, like policy-based routing. It'll explain to you how to do that on Linux. So if you want to really mess with Linux and do some crazy networking stuff, print that thing out. It's probably like 90 pages, but it's a good resource to know about. So, yes?
I think you should talk a little bit about UltraMonkey.
That's just all of the...
It makes it easy to set it up, and that's the point.
Yeah.
Throw the RPMs on top of a Red Hat or the distribution.
There are a couple of tools that can be used to build HA stuff. One that Greg mentioned is called UltraMonkey, which is basically a combination of Heartbeat, is it Mon, IPVS, has it got Mon in it too?
I think so.
Yeah. The guy from VA built that.
I wonder it works.
Yeah. That's what Slashdot uses now. Basically, it's all of this stuff combined in one package that you just install the RPMs for. Now, the one thing to bear in mind is that most Linux distributions do this stuff out of the box, but they won't help you to configure it a whole lot. Debian is actually really good. You can do apt-get install Heartbeat, apt-get install IPVS, apt-get install bridge utils, and it will just install the whole lot. It won't set it up for you, but it has really, really, really well documented configuration files. So I'm running all my stuff on Debian just because I'm like that, but it just works. There is actually a distribution. There was a distribution from Turbo Linux Cluster Server. I think Turbo Linux went the way of like 99% of the companies in 2000, in that they burned through all of their VC pretty quick. But there are a couple of distributions that are designed for clustering. I know there's a couple of live CDs that are designed for clustering. So part of the advantage of HA is that once you get your provisioning set up, say for example, I need a new mail server, you stick a CD in it and it works. Or you note the MAC address and you put the MAC address in your boot P configuration, and it will just do like a kickstart install from the network, install a mail server on it. So you can do a lot of funky stuff once you get the basics up and running. Certainly you can go to some lengths to actually make this thing pretty complicated. So for example, if you have a box sitting there doing nothing, and all of a sudden we're getting slammed with web traffic, we need a new web server. Okay, here you go, plug it in, add it to the network, and it just starts handling web traffic. So it's a really flexible system, and it gives you lots of opportunities for doing lots of things. Obviously with Linux, you can do probably 99% of that on anything. You don't really need a lot of hardware for it. For routers, Like I said,